Testing, testing, testing. One, two, three. Testing, testing, testing. One, two, three. All clear. Okay, awesome. I can see a lot of new faces like coming from who's first time here? Okay, nice. Who's still in university? Coming? Okay, awesome. So now we are getting like a lot of students taking. We normally see from companies around here. Now students getting interested. Hopefully they can get internship. We were just talking about as well. That's the whole point of this meetup. So networking, looking for new jobs. Okay, so actually we wanted to skip this month meetup, but coach is like, nah, we're gonna do it. So we did actually 12 meetup this year, but we didn't skip any meetup because we got everyone on holiday. So we managed to make it for this month. Okay, so okay, so today I have two speakers. We have Dr. Wu, which is the first time. I'm glad that hopefully we get as well after two meetups from now. And we have Dr. University. Okay, so let's go back. So we're talking service locate for interesting topic as well. Yes. For today, again, is because we look at how you find it access aspect. Access aspect. Okay, so Dr. Wu, are you ready for your first slide? Let's go in here. We have actually slides for me to use speaker, but we didn't have time for this round. So I'll just pass it to you from here. And just asked me whether I can be a speaker on Monday. So I wasn't traveling, like, or I was thinking, okay, I can be a speaker, but I have a topic that I have spoken before. Is it fine? He said, okay, fine. So that's the topic today. So topic basically talk about the evolution of large language model. So everybody is very excited about large language model now. But GPT-4, Gemini, which really recently, but it's also good to actually reflect back how the language model has evolved and see
language model. Okay, so this is the slides. If you're interested, later you'll find that there's a lot of extra slides that I put inside. Because yesterday, in fact, I just given the same talk. I gave the same talk in UKM. It's for a lecture for 2 hours. So I shortened it everything for 1 hour session today. Okay. Then if you have any questions, you can actually, if you're shy, you can actually ask in the Slido. So you can actually scan the QR code. It's weird, isn't it? So normally we see people face to face, they don't ask you face to face, they want to ask in the Slido. It's normal. Okay. So a brief introduction of myself. So my name is Guan Hong, or you can call me KH. Currently, I'm working as a senior manager data science at BIT. I'm also a Google developer expert in machine learning. So I'm very passionate about running communities in Malaysia. I actually founded and still running 2 communities in Malaysia. So I founded the TensorFlow Deep Learning Malaysia user group, and also I founded the Malaysia R user group. So if you are doing data science, you probably know that there's 2 programming languages commonly used. One is Python, one is R. So we have the R user group in Malaysia. Then during COVID, about 2 years ago, because of no community event, I actually started a podcast, which is called the AI ML Data Talk Podcast. So basically, it's to connect with practitioners in the industry and talk to them, know what do they do, what are challenges, and then if they want to do any hiring, what do they do, what kind of criteria do they look for in the candidates. Recently, because of recently, I also branches into the podcast into instead of audio, it also appear in video now. So there's a video version which is also available on YouTube now. Like recently, a few weeks ago, I actually interviewed Jason Mayers. So Jason Mayers is one of the evangelists that actually talk about web AI or web ML. So how do you deploy a AI model using a browser? So if you're interested, you can actually go and listen to the this podcast. Okay, so lastly, I just want to promote that if you're interested, please connect with me on LinkedIn. Anything that we can actually connect, and then I actually share a lot of information, latest information regarding AI, ML in LinkedIn. Okay, so this is the agenda for today. So basically, I will start with what is NLP. So we know large language model is related to the foundation of large language model is related to natural language processing. So just give very brief overview of what is NLP. Then the talk about what is language model. Then how does the large language model work? Then we know that large language model nowadays is powered by neural network. So what is the neural network that power all the large language model now? And we know that large language model took off starting from GPT-3. Okay, then when ChatGPT launched by OpenAI, which is GPT 3.5, it actually took everybody's interest into this large language model. Okay, so we know that ChatGPT is the trigger point that actually trigger all the interest about large language model. Anybody still remember when ChatGPT was launched? 1 year ago exactly. November 2022, last year, it was launched. Exactly 1 year ago only, 12 months. And you can see the progress of large language model has gone so much, okay, after the launch of ChatGPT. Okay, so what is ChatGPT? Or like I said, the foundation of all these large language models is related to a few of studies, what we call NLP, okay, which is the natural language processing. So long time ago, before you have all these large language model, people do studies how to make computer understand and generate human-like language. Okay, a field which is called natural language. Okay, so basically in NLP, okay, they actually study algorithm, all the model, and how to actually process all the data to make the computer able to interact with human in a very natural language way. Okay, because you do not want to talk with computer in 0 and 1, okay, because computer can understand only 0 and 1. You want to communicate or interact with the computer with a very natural language way by just talking. Okay, so that was NLP. So basically, the goal of NLP is actually bridge the gap between human language and computer language. Okay, so human can just talk naturally, then computer can understand, and computer can also respond naturally. Okay, so that was the goal of all this NLP. Okay, now we have all this large language model. Okay, so what's the difference between large language model and NLP? So large language model is actually a type of machine learning model. The difference now is large language model has the name large. It's actually trained with massive amount of data set, text data set. Okay, so we know that one of the most important data out there is text. Why? Because human, we communicate or we actually do a lot of communication in front of text. Okay, what kind of text? We have like Wikipedia, we have blog, we have news, we have research paper, journal paper, conference paper. Everything is the histories of all the knowledge that available for humankind is available in text. Okay, so imagine now if you have all the resource of all these text and able to allow the machine to train on it. Okay, imagine what's a lifetime for one human, how much book can you read? And then imagine now all the books that are available in the world is fed to the machine. Okay, so that's large language model. Now, large language model, based on the amount of text being trained, it also can actually generate new text. Okay, that's where you can see all the ChatGPT. You can ask questions. You can ask it to create a poem, poetry, write a song, lyric. You can actually generate new text. So large language model now also intersect what we a new field with what we call generative AI. You can actually use the AI to generate new text. Okay, so basically, large language model now is a AI system where it's trained with massive amount of data sets, able to understand the text, able to understand the concept of the text, and able to do basic function like this. Okay, you can do classification. For example, if you give me a text, I can classify whether it's a positive sentiment or negative sentiment. Okay, so where would you use this? For example, let's say I'm Lazada or Shopee. I will want to push a certain product with positive response to my consumer. So you can actually use all these large language model to read the review and classify whether it's positive or negative response. Okay, then can do response generation, can generate new text, can do translation, and of course the last one, which is to answer, to do some sort of basic Q&A. Okay, knowledge answering. Okay, so that is what large language is all about. Okay, so how do we interact with all these large language model? Have we ever interact with all these language model before? Okay, we probably have, because one of the basic language model that we will have used for quite a number of years already, which is the keyboard predictor. Okay, so when you type the letter T, okay, your keyboard will actually predict what will be the word that you want to type. Okay, so it can be the, there, or that. Okay, so after that, how does the keyboard know what will be the most likely word? Okay, so probably when you type the word T, the most likely word that you want to type is the. Okay, then let's say now you type the letter Y, T-Y. Okay, so what are the possible combination of word that you can actually want to type? Can be T-Y-E, or type, tycoon, typhoon, typanic, or typography. So there are many, many words that the keyboard can actually suggest to you. Okay, so if I were to build a model, okay, how do I know what will be the most likely word that I want to suggest to the user? So what I can do is, okay, I can look at, there are so many words. Let's say the first word T-Y-E. Okay, let's say the first word T-Y-E. So how do I analyze what is the possibility of this word that the user want to input? Then what I can do, I can look at the historical word, how this word has been used from all the literature that appear from 1806 until 2009. I can count how many times this word appeared from all the books, okay, or all the literature available online. Then what I do, I can see that the word TYE, the probability is 1 in 20 million, okay, which is 0.000052%. Okay, I can repeat the same process for the other word. Then what do? Then I have the probability of all these words, okay, then I can re-rank them or put them in order. Then I will say the word with the highest probability is type, which is 0.0148%. And this will be the most likely word that the user wants to input. Then I will suggest this word to the user. Okay, so these similar things you probably have seen before in also, okay, in Google search. Okay, so when you go to Google, you say how, just type the word how. Google will list down all the other search that's been done before by all the other users. Okay, again, how does Google know? So based on all the user input, he will look at all the queries that have been done, starting with the word how, and these are the suggestions coming up. Okay, so this is the basic concept of this language model. Okay, so basically the language model is talking about probability. Okay, whether the word appear or not to appear. Okay, is a probability. Okay, so when we look at historical data, historical word that has been used appear before, then we can count the probability. But how about this probability? This is a future event. You have not seen this data before. You have not seen this sentence before. How do you count the probability? Okay, so there's something now. Then our model. Okay, now we need to find a bigger, better way to actually look, because this word, this sentence is the future. We have no probability of this word before. Okay, so how do we build a better language model? Okay, so the easiest way is if you look at English word. Okay, if you look at English word in the Oxford English Dictionary, it has about 100,000 words. Okay, and then in a normal typical sentence, okay, a normal typical English sentence, you have 10 words. Okay, then if you look at the probability, you can actually count the probability of every single word for a sentence. Okay, which is 100,000, 100,000, 100,000. But if you combine this, then what's your probability? Your probability will be exploded. Okay, which is 10 to the power 50. Okay, something is not right. Okay, so how do we do better? Okay, so let's start with the very simplest way to do a language model. Okay, so let's say I love this song, a famous singer from Bob Dylan. He has a song called Tangled Up in the Blue, and I just want to use these two lines of lyrics to form my language model. Okay, early one morning, the sun was shining. I was laying in the bed, wondering if she has changed at all, if her hair was still red. I just want to use these two lines and see how I can build my own language model. So what I can do, I can form a graph. Okay, I form a graph. Then those words that is repeated, I will form a branch. Okay, so I said early one morning the sun was shining, then the hair was still red, and then was still laying in the bed. Okay. Similarly, for the next line, there's the if repeated, then we also form a branch. Then this is our most simplest language model. From here, we can say, oh, we can actually find the probability. So for example, here, there's 3 branches. So each probability is 0.33%. So there's 2 branches here. The probability is 0.5%. Okay. Then what we can do now, we can say, oh, this could be our most simplest language model. Now we can generate text from here. Okay, so we can actually generate text. Say, okay, early one morning, the sun was shining. I was still laying in bed. Okay, sounds logical. Okay, everything looks fine. Then wondering if hair was still red and wondering if she has changed at all. Okay, fine. Then what you do? Then you ask, you try to form another sentence. The sun was shining. Her hair was, the sun was still red. Her hair was shining. Still sounds okay. Okay, then suddenly you form some other sentences. The sun was laying in my bed. Okay, wrong already. How can the sun lay on your bed? Then I was shining. I was still red. Okay, the word sounds a bit weird already. Okay, doesn't make sense. Okay, so what's wrong here? Because our model is too simple, we just use 2 lines of lyrics. We want to develop our own language model. So how do we do better? Okay, so how can we do better? So we try to fit in the whole song. Okay, we try to fit in the whole song, and we form all the graph, and then we come up with sentences like this. She was standing on the side of my mind. Okay, if the lady stand on the side of your mind, something is wrong with you. The side of a shoe heading to your face. Okay, also wrong. One of my chairs said our life together. You live together with your chair. Okay, weird. Okay, so doesn't work. Okay, our model doesn't work even though we use the whole song lyrics. Okay, so what happened? We found out one of the problem is because the word or probability is only dependent on the word before it. Okay, for example, morning is dependent on one is dependent on early. So we say the probability of the next word is only dependent on the word before it. Okay, so the probability is too simple. Okay, and it makes our language model doesn't behave correctly. Okay, so what we say, early one morning the sun was shining. Okay, we can say, okay, instead of one word before, we say depend on 2 words before. Okay, then we move the window. Okay, we move a window. We said every single word now should be dependent on the 2 words before that. Okay, so we can form something like this. Early one morning the sun. Okay, form something like this. So if you study this NLP before, this is what we call trigram. If you group 3 words together. If you group 2 words together, it's called bigram. Okay, so now you have all the trigram. Okay, you have all the trigram. You say the word probability is dependent not just 1 word before, but 2 words before that. Okay, so now we try to form a sentence again. Well, meet again someday on the stove. You want to meet someone on the stove? You want to cook yourself? Okay, standing there in the back of shoe tangle. Okay, I was standing on the stove. Okay, and then you offer yourself a pipe. Okay, slightly better, but still not great. Okay, so if you look at all the NLP, there are many techniques. Basically, just do counting. Okay, for example, there's some technique called bag of words. It's just, for example, it's a puppy and it's extremely cute. You just count what is the frequency of the word appear. Okay, so if the word appear more frequent, then most likely you can predict that is the next word. So that is the old technique. The better technique is, instead of looking at bag of words, there's something we call TF-IDF, which is term frequency and inverse term frequency of the document. So if I say, if a word appear many times, then I always recommend the word. Then in English, there are many words appear many times. For example, the, and. Then like that, every time there's the, then will be appearing in your document. So instead of doing that, what you need to do, you try to inverse the document frequency. How often that word appear in the rest of the document. Okay, so that is TF-IDF. So if you can see, another last technique is we can actually represent all these words in a matrix. Okay, but of course, again, all the bags of words, TF-IDF or this matrix, when you have large document, then your matrix will go crazy. Okay, so it doesn't work so well. So you can see this is the evolution of the language model from bags of words, TF-IDF, co-occurrence matrix. Okay, so now, okay, if you go back to our these lyrics again, we can see that actually the word red here is actually related to the word hair. Okay, and then the word red here is also related to the word bed. Why? First, the red is actually describe the color of the hair, and the word red here is actually rhyme with the word bed. Okay, so you can see that the word red here is depending 3 words before that, and also the word red here depending on 13 words before that, which is the bed. Okay, so you can say that, oh, now I have a more complicated model where the probability is not just dependent 1 or 2 words, but even 13 words before that. Okay, so what can you do? But you fall back to the probability explosion just now. now you have 10 to power 70 combination, and your language model collapse. Okay, so what is the next thing you can do? The next thing you can do is I try to feed in the whole text into neural network. Okay, I try to feed in the whole text to neural network. Okay, so before I can feed into the whole text to a neural network, okay, I will say that, okay, I will say I want the output of the neural network to be red. The predicted value should be red. Okay, then I'll feed in the whole text into neural network, and then I want the output should be red. Okay, so if you have studied neural network before, neural network only can accept numbers. Okay, neural network can only accept numbers. So all these words here, you have to transform them into numbers. Okay, so how do you transform early has numbers, one numbers, morning numbers? How? Okay, so one thing is you can do is, remember just now we say English word, we have 100,000 words. You can try to just start with A has 0 and go all the way to the last English word, probably is zygote. You can give a number like 92,000 and just give random sequential number like this. Okay, but if you give sequential number like this, you have a problem. The problem is, for example, the word apex and the word Linux, okay, they are very close meaning, but the number is so far away. Okay, so if you feed into a neural network, the neural network will have a assumption that apex and Linux are two different words. They are not similar. So you need to have a better way to represent the word where word with similar meaning should have a closer numbers. Okay. So what you can do is you can represent all these words that have similar meaning should be closer together. Okay. You can actually put this in a what we call embedding space. Okay. So if you do all these large language model, one of the things that you need to do is to convert all these texts to numbers, or we call it embedding. So this is one of the things that appear, which is called word embedding. So word embedding is that you translate all these words into a number space, embedding space, where words have closer meaning should have closer number, closer the number embedding space together. So basically, in the semantic feature space, like grandfather and man should be closer together. So you can see, if you encode all your text, those texts we have those texts we have similar meaning, semantic meaning, should have a similar or closer embedding representation of the word. Okay? So this is where one of the evolution of large language model, you start thinking of the words is where you have embedding. Okay, you have embedding. Okay, so now you can translate all the word now into numbers. Okay, embedding numbers, and then you can feed into your neural network. And then you can train the model to say that the output should be red. Okay, the output should be red. Okay, so if you studied neural network before, one of the most famous deep learning model, which is called RNN, recurrent neural network, and LSTM, long short-term memory, which is used to actually produce train the model related to text. But these two models has this biggest disadvantage, because when we talk about words, the longer the words, the more training time that the recurrent neural network or this LSTM will incur, and as you go further down the road, you forgot what happened in the beginning. So RAN, LSTM, it does not work well with the words with a sentence that many words. Okay, sometimes in language, the subject or the importance of the word can appear at the last of the sentence. So the RNN, LSTM doesn't able to capture if the sentence is very long. Okay. So for example, now, okay, early one morning, the sun was shining. I was laying in bed. I wondering if it changed at all. If her hair, we just hide this. Okay. And then we feed in the model, and then we say, can you predict what is the result? If the result is not red, then go back and fix the network. Okay, so within the neural network, we can say, actually, okay, like I said just now, the word red here is dependent on the word bait because it rhymes with the word bait, and the word red here actually describes the word hair, actually. And the rest of the sentence is actually not very important. Okay, actually does not uh, uh, influence the result of the predicted value. Okay, so what happens is you can fit into a network. Okay, then you have a layer of the network which is called the attention network. So the attention network, what you do is you find which part of the sentence, okay, that you need to put more focus on it. Okay, and then you carry forward these words into the next layer. Okay, so for example, the word bed, hair was still, is actually very important. Put more attention. Okay, and the rest of the sentence is not so important. Okay, then you can predict the next word. Okay, and then you say the next word should be predicted, should be red. Okay, so then what you do, you train this model. Okay, you train the model, and let's say the word brown is predicted. Then you know there's a difference. The actual word is red, and you predicted brown. Then you go back and fix on your attention network and try to lower down other words that is not relevant at all, and put more emphasis on the word that has relevant. Okay, so for this case here, she has changed at all, has no value to the word red, whereas the word bed has more value. Okay, so this whole network, okay, where you put more attention to a certain word, is called a transformer. Okay, so it's called a transformer. Okay, so when you talk about GPT, okay, when people say Chat GPT, the word T is transformer. Okay, so basically the transformer is actually written by Google, a paper written by Google in 2017, and the paper title is also very interesting. Attention is all you need. So in this paper, basically describe, if you look at the sentence, instead of fitting the whole sentence into a network, find that the focus or the attention of the word, then train the model on it. Okay, so that is the attention of network. Attention is all you need, where the architecture is called a transformer. Okay, so basically transformer, what it will consist of is an encoding component and decoding component. So if you input, for example, how's it going? You go through the pre-trained transformer with the GPT, okay, GPT, which is generative pre-trained transformer model. Then you output, okay, you say, oh, he will generate the text, which is, I'm doing all right, thanks for asking, how are you? Okay, so you can see from a normal neural network now, one of the evolution which is very important to this large language model is where the transformer model comes in. Because the transformer model able to solve one of the biggest weakness of the neural network at that time, which is the recurrent neural network and this LSTM, long short-term memory network, because for this RNN and LSTM, it doesn't work very well when you have long sentences. Okay, so basically, the transformer network will have this attention network, attention layer, and then you have the prediction layer. Okay, so for example, let's say I input a value, input a word, it is. So you go through the neural network, and then you predict what will be the next likely word after it is. Okay, then you predict, probably there are many words predicted. Okay, for example, you predicted the, looking, possible, getting, but out of all the word with the highest probability will be chosen as the next word. Okay, so the next word predicted will be a. Okay, so after that you have it is a, then go through the network again. So after it is a, what will be the next likely word? Okay, so you say it's a lot, then go through again. After that you have and, the whole sentence, which is it's a lot of fun. Okay, so this is how the next prediction work in the transformer. Okay, so basically a generic language model is just a next word predictor. Okay, so basically the cat set on, you go through the network, so you change the cat set on into a numbers, or we call it vectors. then you feed into a large language model. Then every single word is called token. Okay. Then what happened? Then there will list of words to be predicted. Okay. It. Okay. Then the word with the highest probability will be chosen as the next word. Okay. So the next evolution of transformer is called BERT. Okay. So like, remember just now, what is the generic transformer can do? The generic transformer can only do predict next word. Okay. But we know large language model can do more on that. Can do translation, can do question answering, can do summarization. So how do you change a model for next word predictor to do other things? That's where this evolution from transformer is called BERT. So BERT basically is you can train a model to do other things. Okay. So from transformer, you have the BERT model. Okay. So basically, it's very easy to predict the next word. Okay. But there are certain words not just predict by probability. You need to predict the word, there's only one answer. For example, the 16th US president was, you cannot predict any other word except Abraham Lincoln. Okay. So your network not just predict the next word, there's only one answer for this prediction. Okay. So your network need to know something. Okay. So, for example, question like this: who was the 16th US president? What is the capital of Philippines? You cannot simply predict other words. There's only one answer for this. Okay. So the neural network must be able to understand more than just predict the next word. Okay. So what happened is, in GPT-3 or other model like Palm from Google, what they do is they stack the number of layers in the model. Okay. So for example, GPT-3 has 96 layers. Palm has 118 layers. So every layer, he will do something. The bottommost layer, he will try to understand the syntax of the word. Then, the higher the layer you go, he learn more about the word. Okay. The highest layer, you learn more about semantics. Okay. So there's some logic that the model will learn. Okay. So you can see, as you can see, this is the evolution of all the large language model. This is outdated already. Now there are more and more models out there. But basically, you can train with more and more parameters, then the model will have evolved. Okay, so where are we now? Okay, so we have the ChatGPT here. So basically, ChatGPT is combination of two things. One is the GPT side. You have the generative pre-trained transformer. So you have the text being trained, you have the transformer model, okay, then you have all the word prediction probability being calculated, okay, installed into your this probability pre-trained model. Then next thing you have the chat portion. Okay, how do you interact with the large language model? You interact by inputting certain text, or we call it prompt. So you, for example, you call a prompt like describe a cat. So what at the back when you enter, what will happen? You do a tokenization. You break it down into individual word, and then you convert the word into vector, into embedding space. Okay, and then you actually go to the probability model there and see based on all this word, what will be the next predicted word. Okay, so he will generate a sentence. A cat is a small, typically furry carnivorous mammal, and kept in the domestic pet. This will be the generative part. Okay, but sometimes the text generated might not be good enough. So what ChatGPT have done, they do what we call RLHF, reinforcement learning, human feedback. They ask the human to actually train, go and label or feedback to the model. So the model keep on improving and generate more natural responses similar to human. So this is what most ChatGPT or the most model have done now. They have done something what we call instruct GPT. So instruct GPT means you actually, instead of normal text data now, you actually swap the data with specialized data set. For example, you have data just for programming code, okay? Or your data just for question answer session, or data just for summarization. You ask human to write the question, and human to provide the answer, and you feed all this back into the model. So the model will learn this how a human response will look like. Then from there, you have like a reward model. So the reward model will actually, whenever the response generated by the model, whether the model is natural response or not, then you actually reward the model. So the model try very hard to generate responses to make sure you get all the rewards. Okay. And lastly, you have all the policy to make sure you can actually remove all the biases, all the dangerous text or whatever. Okay, so what is next? So we know now that after GPT 3.5, which is ChatGPT, now ChatGPT has GPT-4, and even recently, I think 1 week ago, 2 days ago, a few days ago, OpenAI has released GPT 4.5. Okay, so what's the difference between all these GPT now, all these large language model now? Okay, first of all, large language model now is trained with more and more data. Second thing is fine tune. You can do more with the large language model. For example, you have a certain model for coding. Okay, there's certain model just for question answer section. Okay, so you can be fine tuned. And lastly, most important thing is most of the model now are multi-model. So multi-model means the model does not just interact with text. It can also do image, audio, video, okay, all that. So what ChatGPT 3.5 and GPT-4 and beyond can do? So last time it was just text. Now you can have all this all video, images all together. So for example, when GPT-4 was launched, okay, this is one of the questions were asked. What is funny about this image? Okay, so we human look at it, we know, we laugh already. But how does the computer machine able to understand what's so funny about this image? Okay, so you can see here when you ask the model to describe, you describe that okay, this is a phone, it's connected to a VGA, so this is funny because there's no phone connected to an old VGA port. Next thing is you ask the question is what's unusual about this image? Okay, what's unusual about this image? Okay, so the unusual thing is this guy is ironing on a board. 5 minutes. I thought I started at 7:30, so it should be 8:30. Anyway, so this guy in US, you can have many different signs. If you have driven US before, you know different days, different time, whether you can park or not. So what this guy did is just upload this image to ChatGPT, and then ChatGPT will say, "Oh, now it's Wednesday and 4 p.m." He said, "Oh, you can park here for 1 hour." Okay, and something like this. What happens if you cut the string? Say the balloon will fly away. You can understand this is a balloon, you float. If you cut the string, you fly away. Okay, so what are the current large language model out there? So there's the open source, there's proprietary. Okay, open source all started when Meta or Facebook launched the open source model, which is called Llama. Because of Llama, it actually make people very excited, and then a lot of people actually further train the model to do many other things. Proprietary model, we have Google, which is Palm model, and recently Google has just relaunched Gemini. OpenAI have just GPT-4. Recently, they have updated GPT 4.5. And then there's a company called Anthropic. They also launched this model, which is called Claude. There's one more model I didn't mention, which is by Twitter or X. They have this Grok model. Conclusion, text is the most important communication out there. Definitely, the NLP has progressed very significantly in recent years, especially 12 months ago, where ChatGPT was launched by OpenAI in November. So now with all this explosion, we can see that the large language model is getting more and more interesting. And then you can also see there are a lot of framework or tools or all these model already pre-trained that you can actually download and use it and try it out yourself without any internet. Okay. For example, if you go to Hugging Face, you can see all the model available out there. You actually just run on your own computer without any internet. Okay. So with that, I think I can end my talk. Thank you very much.
Questions, so if you ask directly, just hold on mic.
I think
You have as well your.
no, I do. Okay, cool.
You guys, anyone have a question, guys?
Thanks for that. Just wanted to know how the sorting of different domains, how does it sort of narrow down on what domains it might be able to serve from?
You mean domain means what?
Like you mentioned, instruct GPT,
Okay.
data sorted out.
Sure. So there are other people out there, they actually fine-tune the model. Okay, so I'm not sure whether you try, there's something called Olama. Okay, so basically Olama is a tool that you can actually run, you can download the model, and then you can actually run the whole model offline using your computer. So Olama will show you that these are some of the models that you can actually run. Okay, for example, you have Llama, Mistral, okay, neural network. Okay, and you can see there's another version which is called Code Llama. Okay, so basically what happened is they actually fine-tune the model using Llama 2 model just now, but this model more specifically trained for generating code. Okay, so for example, you want a model that very good in chat, then you use this chat model. Okay, so depending on what you want to do. Okay, so I have a tool. I don't know whether I can show this. There's a tool here called. I just share my screen. Let me see whether I can change the screen. Yeah. Let me share. Okay. Not sharing my screen. Not sharing. Okay. Okay. So there's another tool called LM Studio. Okay. So recently there's a very a model released by a company in France, which is called Mistral AI. So they released a model called Mistral. This Mistral, you can see is the name is called Mistral. Okay. So you can actually download this model. Then this model, you can actually use this LM Studio. You can actually ask all sorts of questions and then generate. You see, these are previous things that I asked. And then the whole model is running on your computer. Okay. You can actually try it. So you might think, oh, what's the point running the whole model on my computer? Okay. You can actually ask a lot of specific questions that you do not want to send your data to maybe OpenAI or whatever. Then you can actually just use this model to actually try out. Okay. So
Anyone guys have a question?
yeah, last question.
You have like 5 minutes. Have a question. Hey, also, so how can they reach out to you if anyone wanna?
Yeah, connect with me LinkedIn. So I'm always in LinkedIn, very active in LinkedIn. So just connect with me, and then we can. If you have any question, you can ask me there.
Okay, thank you so much, Dr. Fu.
Thank you.
To have you here. Okay, Robin, ready? Second. Okay, Robin, who knows Service Rocket here? Okay, we have some only 1, 2, 3. Okay. Yeah, so they say they have a good DevOps team before that their reputation, and Ravi will talk on how they hosted their Nginx on Lambda, which is running in production. You just said now, right? Yeah. So I'm going to let you share on that. So let's all welcome Ravin, guys. This whole this one. This one only for YouTube.
Okay.
This one.
Okay. Okay. I'm not sure if you guys know me, but it's a month I can talk here at AWS User Groups. So how many of you guys love Nginx? Raise up your hands. How many of you guys run it on an EC2 instance? How many of you guys run it on a Lambda function? Okay, so here today, I am Raven Pasupati. I'm a Docker captain for Malaysia. And this talk was actually brought up at Los Angeles, United States on October 2023 this year. I actually did a talk at DockerCon 2023. And I'm a platform engineer at Service Rocket. Okay, so this is the first thing, all right? So brace for impact. There will be a few technical things going behind the scenes. So just brace for impact. Okay, but I'll make sure that I don't confuse you guys while I'm trying to promote this or while I'm trying to share this entire concept behind the scenes. Okay, one thing you guys need to know, if you are able to get Nginx running on Lambda, you can literally get anything running on Lambda. All you need is a Docker image. All right, so let's get started. Yeah. So who am I? All right, so as I told you guys, I'm a Docker captain, and at the same time, I do a lot of different things. Okay, I run a few startups in Malaysia, and at the same time, I do yoga, MMA, and a lot of things around this. I mean, within the entire vicinity, and I also teach as well. So yeah, this is what I do. I'm actually an MBA student, and I graduated in software engineering. So yeah, this is me. And don't ask my age. I may look young, but I'm 22, by the way, still young. Anyways, so let's get started. Okay, without further ado. Okay, so why did I even come to this point of running Nginx on AWS Lambda? It sounds crazy. Okay, you cannot find any implementations on the internet if you do a Google search. You'll not be able to find it. All right, and why was this a thing? So initially, money was the problem. I mean, it still is the problem. Okay, where I was just running Nginx on an EC2 instance, running either on maybe a ECS container or something, maybe EKS or something like that. And it's not cheap. Okay, we know our pocket just blows. If you have a credit card, it just keeps on going until you reach a limit, and then your bank will be like interest over interest. Okay, then because of this, I decided to take a step ahead and then find out like how can I even run Nginx on Lambda, because I've seen, I mean, it should be possible, right? Lambda is like a server. Come on. Okay, you should be able to run it. It's a micro VM in the end. Okay, so you should be able to run it. So yeah, you can. Okay, it's just that it's not documented on AWS documentations. Okay, and at the same time, I would like to say that this is not, I would not say this is suggested by AWS themselves. Okay, so which I will go through the nitty gritty of it in a while in the next slides. Okay, this is not suggested by AWS. And how would you, the main concept behind this is that how will you actually run a serverful application or software in a serverless environment, which is AWS Lambda. The serverful word is something I made up, by the way. I'm not sure if it's in a dictionary. All right, a quick disclaimer. Okay, this implementation is literally a POC. It's basically a concept, right? And it definitely will breach the serverless kind of concept that AWS comes out with. Okay, it may literally flip the solutions architect exams and everything upside down. Whatever we learned there. All right, and this is more towards POC. Once again, I'm telling you, this is not associated with Amazon Web Services or Docker incorporates. Okay, so yeah, and you may use it in production environment at your own discretion. And I'm using it anyways in the company. And we have saved a lot of money actually. I would say more than $10,000. All right, so I broke it down into a few steps here. Okay, I will go more towards a little bit on the live aspect of things, a little bit on the implementation, and lastly, I'll give you guys the answers, which is the solution itself. Okay, first one, how does AWS Lambda work? And remember, this is going to be a technical one. Okay, I wrote it down there. So AWS Lambda, and this is the first slide, just relax. Okay, AWS Lambda is basically uses a micro VM behind the scenes. This is something I'm not sure many of us know, but they use something called Firecracker behind the scenes. Firecracker is a micro VM, okay, that is built by Amazon Web Services in order for them to support AWS Fargate and AWS Lambda, the performance itself. And this is completely built by AWS team themselves. Okay, and every runtime that is made available on the AWS console, okay, is basically something for you to use easily. But do you know what is the entire process of building a runtime from the scratch? I don't mean Lambda layers. Lambda layers are easy. But what I'm saying is a runtime that supports AWS Lambda. How do you build a runtime? And I'm going to show you guys today. All right. So the next one is in order for you to get more clarity of what I'm trying to say, how AWS Lambda works behind the scenes, you have to look at the source code of Firecracker itself. As I told you, AWS Lambda completely relies on Firecracker, which is a micro VM framework. And Firecracker itself is built on top of Rust programming language. And yeah, it has everything, all the chroot, chmod, and all these things that happens behind the scenes of a Lambda function. And that is exactly why you don't have root in your Lambda function itself. Although you may try to have root, you may try to force it, but you'll fail, okay? So yeah, that is that. So how did I pull all this together, right? I know it may sound like, it's going to be easy, man. The Firecracker is there. We just copy, paste the code, and then we just run it, No. Okay, so before you go into the implementation steps of the runtime, you need to understand something that certifications don't teach you. Even YouTube videos doesn't teach you. Even maybe Medium articles doesn't teach you as well. Something you learn by yourself through pain. Okay, you guys will know the entire time frame it took for me to come to this point. Yeah, so let's go. So I'm not sure if you guys can see this clearly, but this is the, I think my Zoom thing is disturbing it anyways. So this is the entire thing that's running, right? We know that a Lambda function can support ALB. We can attach an ALB on it. You can attach an API gateway on it. And I'm not talking about serverless invocation, right? I'm not talking about SQS triggering Lambda. I'm just talking about HTTP API over here. Okay, so we have ALB, we have our API gateway, and in a normal architecture, you would only have the API gateway logo there, and you would have the Lambda function logo there. And when someone asks you what's the architecture, you just throw this to them. Two things: API gateway, Lambda. Okay, that's the architecture diagram. That is what we know from the certificates. But something that you will learn in pain, okay, is what happens behind the scenes. How does AWS Lambda or how does API gateway trigger an AWS Lambda? Okay, so this is very, very technical. So I'm going to decipher it a little bit into a layman term. Okay, so API gateway will always use something called response stream to invoke a Lambda function. A response stream is basically like some waves, if you want to imagine. It's like some waves trying to trigger Lambda functions. Okay, and when that wave hit your Lambda function, this is where it decodes the bytes. Okay, it basically decodes it into bytes. When it decodes into a byte, that is exactly how you can send so much of headers into your HTTP API, and then later on get it being spit out inside the source code, right? When you do a console log or print or whatever it is inside a Lambda function. Okay, and this is how it works behind the scenes. All right, this is response stream. So just remember, API gateway uses response stream to communicate to Lambda function. Another one, ALB or ELB or whatever you want. Okay, it can be even different settings also. Okay, and ELB will use something called buffered stream. A buffered stream is also like a response stream, but it comes in a different format itself. As we know, ELBs are basically, they can literally trigger an EC2 instance as well. You can basically point it to an EC2 instance in a target group, and then it just works. Okay, and you can do the same thing for Lambda function as well. You can just attach your Lambda functions to a target group of your ALB, and then it just works out of the box. Okay, all these things. So there is a difference. They are not the same. Although the final results are the same, you would still get your page, you would still get your data, but they're not the same technically. Okay, and I'm going to go through in depth on each and every element over here. So just brace for impact. Okay, if this is too much for your brains, okay, just watch it on YouTube if you get stuck somewhere or something. All right. Anyways, so we first discussed about how API gateway or ELB or ALB triggers a Lambda function. Then once it has triggered the Lambda function, what happens after that? Okay, in our modern technologies, we have our serverless framework, we have our Zappa, we have all these different things we deploy Lambda functions to. Very easy. Just deploy it and close your eyes. Probably if you don't deploy the wrong account, then it should be fine. So yeah, in this case, it's easy. Okay, and when you trigger a Lambda function, you get a response within 2 seconds, maybe 5 seconds. Okay, depends. Okay, depends on how good you write the code there. Okay, and that is so fast, right? But what happens in that split seconds? What happens? There's so much of process that works behind the scenes. Okay, and as we know, Lambda is a micro VM. It is not straightforward at all. Okay, behind the scenes, they did a lot of tweaks in order for us to stop, in order for AWS to stop us from using it as a server. But in this case, we managed to make it as a server. Okay, but yeah, I'm telling you once again, this is not associated with Amazon Web Services, and I do not work with AWS, so I have no connection with them. All right. So the first things foremost is once the Lambda function has received your payload, it will decode the stream into bytes. Once it's decoded into a bytes, it will automatically include the X, AM, Z, and context headers. This is needed for your Lambda function to actually know that the the request itself is coming from a legitimate source, which is an AWS service, which is ALB or maybe a API gateway, or maybe it can be a event-based trigger as well. Okay, that is how it knows. Other than that, it won't respond to you. Okay, this is how it works behind the scenes. And then later on, since we are using Rust for our runtime here that we're going to build, okay, that's already built, but I'm going to show you guys how to build it as well. Okay, so in this case, we're going to use Rust. When we use Rust, we use a HTTP packet or a HTTP package called Hyper. Hyper will allow you to hypervise or whatever you call it, okay, make it as a request context, have all the headers, all that packets, all that cookies and everything packed together, and then send to the Lambda context or Lambda invocation handler itself. Okay, remember Lambda, the way how Lambda is, right? You guys can deploy it easily, but how does Lambda return you the response back to your API gateway? They all communicate using what APIs? There is an internal API that AWS uses. It's called invocation/next. Okay, that is what APIs they use. Okay, it's basically like the instance metadata on EC2 instances. Okay, it's basically that. All right. Then what happens is that Hyper will automatically set the request context. It will basically build the packets and everything. And later on, it will just append whatever headers CloudFront sends them. As we know, CloudFront has its own headers, automatically appended headers. And of course, ALB is depending on you. Whatever headers you set there is what's coming through. Okay. And all this must be included. Otherwise, your request will not go through because AWS do have something called a health check before the request comes out to API gateway. Okay, this is very technical. I want you guys to imagine, okay? Just imagine where API gateway triggers a Lambda function. Then once the Lambda function gets the request from the API gateway, it will do all the processing by itself, and then later on comes out back to the API gateway. Okay, so this is the process I just explained. That circling that I just showed up here is the job of a runtime. Your runtime will be doing the circling over here. It will do the circle. If it hits the wall, then it hits the wall. If it doesn't hit the wall and go through, that means you went through. Okay, this is what it is. And throughout my entire experience of building this, I hit the wall 100 times, which means I failed 100 times. Okay, which I'll go through that in a while. All right, then health check. The final step is to do the health check. A health check is done automatically. Not automatically. You have to program it yourself, as I told you. If you build your own runtime, you're going to do everything yourself. There's no help from anything else. If you just use a pre-built runtime by AWS on the AWS console, it's easy. Just deploy your code and then it's done. Everything's running. Okay, so health check is performed within the runtime. Okay, and then it will be forwarded to pod. This is very important, yeah. Remember, when we are trying to run a serverful application inside a serverless platform, it will basically be container on top of a container. It's like a sandwich. You have the two breads, and then in between you have a fillers, right? It's like that. It's like a sandwich, not an idiot sandwich. Anyways, so we have port 9001. What is port 9001? Port 9001 is the default port for API gateway invocations. Okay, internally, AWS will use port 9001 to communicate from API gateway to your Lambda function. Remember, this is not documented anywhere. Even if you create a support ticket on AWS with enterprise plan, I tried that. I tried to ask them. They said no. Okay, this is what it is. Unless if you ask someone who actually works on AWS Lambda at AWS themselves, they probably will know. I'm not sure if they should disclose it or not, but yeah, I got no help. I found it all myself. And I'll show you guys how I did that. Okay, and next one. Port 9001 is the default port for the communication between them. That's the communication layer. And then later on, okay, if let's say, in this case, we're going to deploy our Nginx, we cannot use port 80 or port 443. Why? Because Lambda has no idea that the container has SSL enabled. It has no idea. SSL is done by API gateway. Termination of SSL is done by API gateway, not your Lambda function. And in this case, the Lambda function doesn't have root, which means you cannot expose anything below than port 1000. Okay, this is a normal rule that works the same for EC2 instances. If you don't have root, you cannot expose anything below port 1000. Okay, simple as that. And we cannot get root anyways. I tried my best. Okay, and yeah, this is not shown to end users, so I'm just giving you guys some insights. Okay, hopefully I don't get sued by anyone. Anyways, so let's go next. So how long did this take, right? Interesting, very, very interesting. So you guys can see this. This is my entire thought process. It took me 9 months. 9 months. Okay, so on January, I ran into a huge billing by AWS himself for running Nginx on EC2 instances, which served as a proxy. I only had a Nginx instance just to serve as a proxy, and I got like a $150 bill because, I mean, I'm a AWS certified professional, solutions architect professional, but sometimes I forget some stuff. Okay, then my forgetful nature made me to pay that bill. Anyways, so in this case, I was literally hosting my Laravel application. I love Laravel, by the way, last time. So in this case, I deployed it on EC2 instances with Nginx and all these things. Then I got a bill. On February, I started to look out for alternatives. And I found a lot of different alternatives. Bref framework, BREF framework, Laravel Vapor. Okay, not a vaporizer, but Laravel Vapor. Okay, it's a service. So in this case, I looked into all that. And I was like wondering, this is the pivotal point, right? You know, all that thing, the thing that everyone has, ego. Okay, the ego was like, he can do it, I can do it too. Okay, then that is when I got into that hole that I didn't want to go into. Okay, but somehow went into the hole. So when I went into the hole, I was like, you know, very curious how they did it, because if they can do it, I can do it. They're human, I'm a human. Okay, so that is that. Then on April, I tried to look for a lot of different solutions. There were nothing. To be honest, there were nothing on GitHub, nothing, you know, and Stack Overflow, what we call it, YouTube, definitely not YouTube, Medium, and all these things were nothing. It was completely clean. Okay, then I was like, how did this guy made it? If there are no references, how did he make it? Then I found my way then. That is when it all started there. I found my own way. I don't need help. So, okay, I'll teach you guys how I did that. Okay, it's very interesting. And on May, I found out that AWS Lambda behind the scenes uses Firecracker, because I was also interested in how Lambda actually works. It's so fast. It starts up so fast. How does it work? Then I found out that they use Firecracker. And Firecracker is documented well on AWS documentation. That's the only thing. Okay, well-documented framework. All right. So then I went into a part of reverse engineering. This is the most interesting part. Reverse engineering is, sorry to say it in AWS meetup, but I did some reverse engineering. What did I do? So if you deploy a language, I mean, your code using a runtime that is built either on Golang or Rust. I mean, Rust, it doesn't support yet. I mean, a little bit of part of it. But then if you deploy a Golang application on Lambda, you will have access to a lot of different things. What do I mean by different things? When you deploy a Python function and print out all environment variables, some environment variables are somehow hidden when you do it. But if you deploy a Golang application on your Lambda and print out the environment variables, there's something very interesting going behind that. It's called as Lambda Runtime API, an automatic environment variable that is set by the entire micro VM framework by AWS. I'm not sure if they've forgot to hide it or what, but yeah, it's there. So that is when I found out that whatever that's happening behind the scenes is all APIs. Okay, there's no, they didn't, I mean, whatever they did was a good thing, building that Firecracker framework and all these things. Okay, but as you read the source code, you'll get more concept about how it actually works behind the scenes. Okay, then I was like, oh, this is how it works. I tried one thing and it failed, of course. That is also adding up to the 100 failures that I had. 100 times I hit the wall while doing things. Okay, and 100 one time, I mean, within the 100 times, I think only one time I got it green. That is when it worked. Okay, so that is that. And then from June until September, that is like a 4 months mark over there. Okay, I get it about 100 plus pipeline failures. And DockerCon was on first week of October. I finished this project on the first week of September. Okay, that was very close because I wanted to show something to the world. And then I was like, okay, let's do it. Let's do it. And then on first week of September, I got it. Okay, that's how it worked. But a green doesn't mean it's always a green. Okay, the grass is never greener. Okay, the pipeline showed is green, but then when you deployed your code, I mean, you deployed the Docker image itself to your Lambda, it as a container image, it didn't work. Okay, I'll come to that in a while. Okay, so that is that. Next, so will I suggest you be like me? This is one slide more towards my personal life. Okay, just a touch. Okay, no, don't try it. Okay, so while trying so hard, to achieve something, I lost a lot of things in my life. Okay, one of it could be, I mean, going high level, right? It's more towards my social life. I lost my social life completely because I work from morning until 4 a.m. every day. I sleep at 4 a.m. until 8 a.m. I wake up, I do the same thing, including Saturdays, Sundays. Okay, so is it good? No. Is your body allowing? Mine is yes, but maybe yours not. So yeah, don't try it. Don't try it. Don't try it. Okay, I don't think it's worth. Okay, I don't think it's worth. But if you guys want it, you guys can, or your own discretion. I'm not suggesting anything. All right. So what tools are there in the market? Laravel Vapor, Breath Framework, and my solution over here maybe. Okay, because I'm planning to post this on Dev2 and gather some stuff, and then even Docker asked me to post this on their blogs. So I'm gonna do that soon. And these are all I know of actually at this moment in terms of whatever tools that are there in the market. Okay. So next, what kept me motivated? That's a big question. That's a big question. So despite the external events in my life, although remember external events shouldn't stop you. Okay. I was still focused on what I wanted to achieve. Right. That's the only thing, because by any means possible. And some wise word from me maybe. Okay. If you guys want to keep it, write it down somewhere or anything. Okay. Don't stop. The world may fall apart. Okay. And there definitely shouldn't be times, where you want to give up. But if it happens, just think why you started. Okay. When you want to give up on something, just think why you started. And I had a lot of reasons to give up with that 100 pipeline failures every single time. Remember, it takes like 18 minutes to build. After it builds, red color. After it builds, red color. There's so much of time I wasted over there. Okay. And there's so much of reasons, but there's one thing that I wanted to do, which is to try something new. Get out of my comfort zone, not just deploying using serverless framework or Zappa or anything. And then I'm like, oh, I'm a DevOps engineer. Maybe that's true, but then yeah, come on. Okay. So the solution. This is the most interesting part. Okay, this is the most interesting part. Everything that I'm going to show you guys here is open source, is on my GitHub. I will share the link later. Okay, don't worry, nothing is closed source. All right, I know, I want to be kind. You guys should also save money. Okay, and yeah, there is that. So the only thing you need to know here is that since our context here is to running Nginx on AWS Lambda, okay, all you need to know is how to configure Nginx. But configuring Nginx is not the same as you configure it for an EC2 instance. So as always, we have a lot of roadblocks. One of the roadblocks, this is one of the roadblocks. Okay, and this roadblock is directly from AWS themselves. Okay, as we know, knowledge check, any solutions architects here, or anyone working with Lambda, you can only write in /tmp folder within a Lambda function. Okay, /tmp folder. That is the only place you can write within the Lambda function. And when we know, or when we look at the Docker images that is there on Docker Hub, most of these images start from a base image, which is probably Ubuntu, Alpine, Red Hat, CentOS, and all these things. And as we know, when those images that runs on Ubuntu and stuff like that spins up, it will definitely store logs in some other different places inside the container, maybe /var/log and all these things. So this is my second challenge. I mean, probably many challenges, but this is one of them. Okay, so this is another challenge. How do I actually move every single IO reads and writes to the temp folder? How do I do that? Okay, so this is where my Docker Captain experience comes in. So as Docker Captain, we actually play around with Docker every day. So in this case, I literally dissected the Nginx Docker image by itself. And then from there, I was literally playing around with what can I change in order for it to start reading and writing inside the temp folder. What can I do with that? Okay, this is where it got a bit more interesting, because the base image is basically running on Ubuntu or maybe Alpine or something like that. Okay, I definitely cannot change the base image, but I can definitely change one thing, which is the std out. Okay, as we know, when you do the command docker run nginx-d detached mode, it will show the logs either in the CLI or maybe in the Docker desktop app. Okay, that process of using the log is called as std out. If there's any error, it's called as stderr. And if you're trying to input something, it's called stdin. standard in, standard error, standard output. Okay, three major things. We don't need standard input in Lambdas because we don't have keyboard attached to a Lambda function. Okay, but we definitely do have std out. Std error, just let it be that. Just screw it a bit. Okay, but std out, okay, just let it be that. I mean, we need std out. So as we know, AWS will definitely try to log everything to CloudWatch. Okay, there is no logging to the local disk or temp folder or anything. Okay, there's no such thing. So if you're building your custom runtime, as I told you, you have to do everything yourself. That automatic log to AWS CloudWatch, okay, is something that is a functionality of the runtime that they built for you. If you are trying to build your own runtime, that is your problem to fix that. So how did I fix that problem of mine? Okay, so in this case, I know that std out that is coming out of the Docker container is basically that, right? It's basically std out. So I want to find a way how to pipe that std out into my CloudWatch log group. How did I do that? Lambda is a bit smart, a bit. Okay, so in this case, when it finds out that the logs are actually being exerted out with std out, it will automatically plug that out and throw it inside CloudWatch. But by default, Nginx image doesn't do that because Nginx image is busy writing the logs in somewhere else. Okay, it's not writing the log files to an std out. It's busy writing somewhere else. Okay, that is not something we want. We want it directly to CloudWatch. So how do you achieve that? You have to try to pluck out that std out functionality itself. You need to do some changes, and these changes are not within a runtime yet, but it's inside your nginx.conf. I will go through that shortly. Okay, so this is what I said. You must be very good at configuring your Nginx because you're going to play with it a lot. Okay, a lot. And remember, your Nginx daemon that runs behind the scenes is not a daemon anymore when you run it on Lambda. Okay, because your Lambda function goes out and comes back in. Cold start and all these things. When it terminates itself, if you have a keep warm schedule, that's a different story. But then, and if you don't have a keep warm or something like that, it just goes off if you don't use it. A container. So the sandwich guy, that is the filler between, will be exposing himself to port 8080. The communication guy, which is coming from API gateway, will look at port 9001, which automatically port forwards to port 8080. Okay, there's a lot of technical stuff behind the scenes. That's why it took me 9 months. Okay, it is a lot. Initially, I couldn't digest this as well, but later on, pain changed me. Okay, anyways, so the only thing you have to know is how to set up Nginx. Okay, that's the only thing you have to know. Next. So building the Lambda runtime is very simple, guys. Not really. Okay, the challenge in building the custom runtime is actually figuring out the code. Okay, what code you could write to build the runtime from scratch. I showed you just now some architecture diagram. Okay, one side I showed you guys some circling. You have to change that circling into Rust programming language in order for you to circle around and get out of Lambda function. Okay, so this is what it is. That circling needs to be turned into Rust code in order for your Lambda runtime to understand, and in order for your micro VM, which is Firecracker, to understand. Okay, so this requires a lot of thinking. I got a headache every day, every single day. I slept with headache, but it's fine. It's normal. Anyways, as per design, AWS sends heartbeat to the Lambda function. That's what they do. Okay, they do have a probe, readiness probe, that they automatically send from some other monitoring service they have internally to the Lambda function. And then using some APIs actually. And basically the same happens when a runtime sends the response back to the Lambda function. Everything is through API, okay, which is called as Lambda Invocation API. If you Google that Lambda Invocation API, it will give you a link. Have fun with that, because that's not going to help with this entire thing. Okay, so yeah. Another thing is that a very in-depth analysis and understanding on how TCP layer works behind the scenes. Everything everything behind the scenes of this entire implementation works behind a TCP. So you need to understand the protocol that works behind the scenes. This is how you get to reap the benefits of how actually Lambda works and how you can actually make Lambda work for you. Okay, instead of you working towards Lambda. Okay, change the dynamic over here. And even also how HTTP works by itself. And the next one is that the runtime must be very lightweight. Do you guys know how fast that does your Python application that you deploy to Lambda function just spins up so fast like that? Because it's lightweight. If you want Nginx to spin up like that, make sure it is lightweight. Hence, that is why we are using Rust. Okay, so make sure it's lightweight. If you make it slow, if let's say you have so much of iterations within your runtime itself, let's say it takes the O to the big O notation of n square or something. Okay, that means that it's going to take some time. Your time complexity increases, your space complexity increases. That is how you actually, ensure that. I mean, that's how you really can ensure that Lambda function is really slow. Okay, because you keep on adding more iterations. So it must be point blank. It must be very straightforward for your Lambda function to actually invoke the runtime, push in the Docker image in, change the configuration, expose the ports, okay, and then push it out to you guys as a response. Everything must happen within milliseconds. Please do that. Last one, a custom readiness probe must be created by you. This is what I said about a probe that is there within the entire environment where AWS will be sending heartbeat to a Lambda function, and therefore it's going to be vice versa. Okay, so when you do this, you need to implement it yourself, because if you don't have the heartbeat, if you don't send an okay response back to AWS when they do the heartbeat, your runtime will never start. This is all about the mechanics of AWS Lambda. As I'm telling you guys, I'm not a software engineer for AWS. I'm not working for AWS. This is all something that I found it myself. So use it more towards your discretion. Okay, please take care of the, don't play around with it too much. Okay, before AWS starts changing things. Okay, so yeah. Next, Docker. So this is more towards Docker here. This is called as the sandwich Docker image or sandwiching method. How do we sandwich it? I told you guys. Okay, so this concept is pretty similar, okay, to using a base image and then you injecting a sub image into the final production build. This is called in layman terms. Yeah. So basically, you have your first layer, you have your sub layer, and then you have your final layer. Everything slapped together. That's your production build. That is what you're going to eat. That's your sandwich. Okay, so this is exactly the same method over there. Okay, and runtime platform or Lambda architecture is very important. Are you going to use x86-64 or are you going to use ARM64? Okay, I would prefer you guys to use ARM64 because it's a bit cheaper. Okay, x86, I mean, maybe they will decommission it in the future, so you might want to future-proof yourself. In our implementation, Nginx image will be used as the base image. Okay, we're going to use ARM64 architecture. And then we'll be injecting the runtime images within the Docker file. Okay, please note that the custom runtimes must always be in a folder called as, with a path of OPT extensions lambda-adapter. If you have your lambda adapter or runtime itself in a different folder except the one here, it will never start, because AWS definitely will look for the lambda adapter in a specific folder in order for it to start. Okay, that is how it is. That's how it works, macro VMs. Okay, and that is how they do it also. Okay, lastly, we push in any configuration files such as nginx.conf into the final image directly. This is what we do. This is the runtime. Okay, so I know it's a bit shady over here and up there, maybe cloudy a little bit, but let me clear it up. Okay, so let's visualize this. So in terms of visualization, we have the first thing, which is our Nginx base image. The second one is the custom runtime we built. This is running on top of Rust. We're going to use Cargo to build it. Okay, and then we're going to upgrade any packages, like example, like running apt-get update, yum update, yum upgrade. All these things, you can do it. You can do it exactly like in a Docker image. There's no problem with that, because in the end, what is going to build an image is your pipeline. Your Lambda is not going to build an image. Your pipeline is going to build an image. Then push it to ECR. ECR will then feed it to a Lambda function. Okay, simple as that. Okay, next one is inject the config files. Okay, just inject your nginx.conf file directly to it. And then lastly, bootstrap. So bootstrap, this bootstrap is not a HTML, the CSS bootstrap. Yeah, this bootstrap is where you actually give out the manifest to start your Nginx container. Okay, so when you do the bootstrap, you will actually put in the commands to start your Nginx container with daemon mode off, and while you feed in the custom config files. One thing to note, if you follow the same method, you can literally run any single thing that is there on Docker Hub on AWS Lambda. I have literally run WordPress on Lambda and it works fine. Okay, tested. Okay, so that's that. And in terms of storage, you can use EFS. There's a different ball game. Okay, but it works. Next one, behind the scenes. Okay, for this entire implementation, the solution itself, we are going to use two things in terms of Docker stuff itself. One is Nginx, the public image. The custom runtime built by me, okay, built using Rust, will be open source soon. I'll open source that soon, but you guys can download that from Docker Hub. It is there on Docker Hub, completely built on Rust. I'll show a little bit of snippet on the runtime in a while. Okay, next one is AWS Lambda, AWS API Gateway, AWS Elastic Container Repository, and lastly Terraform to orchestrate everything together and slap it all together. Okay, to make your life easier. So will this work only for Nginx? No. Okay, it will literally work for anything. Okay, you just have to put some extra effort to find out if it really will work, because there's a lot of things like Bitnami images. They're too fat. Okay, example like Jasper reports. You know, even if you're running Jira software, Jira server or whatever it is, okay, Jira Service Desk, everything on Lambda you can, but it'll be very fat because it's Java. Okay, in order for Java to run and start itself, it's going to be very hard. Okay, it's probably going to kill a Lambda function itself. Okay, and so there's a caveat towards all this, right? The caveat basically is you need to decompile all the images to its own parts, which you can get the source code of the Docker files of the specific image, example like WordPress and stuff like that. Ensure nothing is writing to any other folders than /tmp folder, then you're good to go. There's a lot of things here, I know. Building the runtime is one, then you figuring out and fighting with Docker files is one, and then later on you testing it once. But in the end, if you're trying to achieve something, maybe lesser cost or something like that, you can. And in terms of cost savings, this is the final part here. Cost savings. In Service Rocket, we nearly saved about 10,000 USD a month by just running the solution on AWS Lambda. What are we running here? We are running multiple instances of what we call it as Nginx proxy servers. So one Lambda function will serve up to 500 different domains inside the Lambda function. Everything controlled by Nginx conf. Lambda scales very well because of the concurrency. And in terms of pricing, we are literally at just $100 to $200 per month. Okay, that includes API Gateway, CloudFront, at the same time, the Lambda function itself. Okay, there's a lot of change. $10,000 to $200, there's a lot of difference. Okay, and we've been running it for 3 months. Okay, and it's been good. There's no complaints so far. Maybe AWS will complain soon, but we'll keep it that till next time. Okay, so the source code is over here on the GitHub. Please scan the QR code. You guys will get the source code. Everything is there. Just read the README. There's the pro tip there, quick tip. If you guys want to have a quick tip, that's the quick tip. Okay, just read the README. Okay, so that is that. This slide, this QR code won't track you. Don't worry. Okay, it doesn't track you or the clicks itself. So, all right, that is that. And once you guys have the QR code scan, I'll move to the next one. There's one more slide, I think, 1 or 2 slides. Then I'll show you guys a little snippet of the entire runtime. So yeah, it's done already. So thank you guys so much. Okay, before we do the thank you speech here, let me just show you guys one small thing. Let me show you. Does this show? Yeah, it does show. So this is the entire adapter itself. So basically it's built on top of Rust. As you guys can see, I'm building it on top of Cargo. So there's so much of things that's happening here. There's also Hyper by Rust. Okay, and then if you look into the librs, everything here is done for the thing. It's meant for the entire, what we call it as the adapter itself. We're using all the methods from Hyper and also Lambda HTTP packages that is coming with Rust itself. Below that, we're going to extract the HTTP TCP protocols that's working behind the scenes of Lambda. Remember, I reverse engineered this thing. So there's a lot of things may not be as per spec, but it works. Okay. Later on, buffered and response stream. This is what I told you: buffered stream, response stream. This is how we identify. It works with API Gateway. It works with ALB and stuff like that. Later on, you're gonna derive the readiness probe sync, async init for your Lambda function so that it can start asynchronously with the runtime and the codes itself. Later on, TLS mode. If you're attaching if you're attaching ELB to your Lambda function, how do you have the SSL certificate piped into your Lambda function so that it can be terminated between them. Okay, all of this is done by this function over here. Okay, and at the same time, if you have some domains, example like setting up a local host, I mean your own domains and stuff like that with CloudFront. Okay, so CloudFront custom domains, this is how it automatically gets piped through. Okay, all of these are going through the process of how Lambda functions actually work from point to point. Okay, this is how it works. Next one is, as you can see, there's an SSL certificate file here, environment variable. This environment variable is automatically set within the Lambda environment by CloudFront or API or ALB itself. Okay, so don't have to worry about this thing. It's automatic, and everything here works with local host. Okay, Lambda within itself talks within all the things that are happening there in localhost. Next one is the health check, and there comes the next one, which is the final part over here for today, is the AWS runtime API. So as you guys can see here, when the runtime actually registers itself, it comes to a port 9001. And once port 9001 is picked up, it will then run this runtime API here to register the extension on AWS. And later on, it will then invoke the event next action, where it automatically calls in for the next invocation, and it keeps on going. And finally, you hit a dead end, which is the final application itself. Okay, so yeah, this is all it is. Thank you guys so much. And if you guys want a production lookout, just go to nginx.myname.mi. And this is running on AWS Lambda. And to prove that further, let's do a curl. If I can have that curl. And then now you can see that it's using CloudFront behind the scenes. And then XAMZ remap server coming in from Nginx 1.23.4. All right, thank you guys so much. And of course, there's a feedback form over here. Please do scan this QR code. Give me some good feedbacks. It will help me in the future. Not now, in the future. Thank you guys so much. Back to the.
Okay, thank you so much, Ravi. Do you guys have any questions? Yeah, we have. Okay.
It only comes when the invocation starts. No, it doesn't. It doesn't. So that line only runs when invocation happens. So when invocation happens, you run the overlay, which is the container. Within the container is your code, and then that's how it runs. So the container is the one that communicates with the runtime API. Yeah, 10 minutes. You will just disengage like normal one, like how Python does it. It just does it like that. So it has the mechanism to automatically slow down right after it reaches 15 minutes. Because when 15 minutes reach, AWS literally do an ACP shutdown of it, like pull the plug. So that's basically all it is. Yeah.
Any other question? You have one, right? Okay.
That's a hard question. That's a hard question. That's a hard question. But I would say at least 13 hours a day. Yeah. So that's because I start my work at 8 something, and then it ends at 6, 7. Then after that, I go back home. I go back home 30 minutes late. Yeah, pretty much that. Because if you look into a different context, right, you have your base image. The runtime is just a layer. It just goes in between. Then finally appendage. This is the other things like export port, the files, add, and all these things, Docker stuff. So everything like that. But at the end of it, I would not say it is an image from a runtime, but I would say it's an image out of a runtime. So that's the difference there.
So thanks a lot for all of your support. A big round of applause for all of you here. And yeah, and moving into the next year, we want to start it off with a bang. So we would like to pre-announce that January 18th, we will be having our first meetup, and we will be doing what is known as the recap, which is we'll be going through all the important announcements that happened at Reinvent. So what's Reinvent?